synchronized watch, and everybody around around the world that is doing this test gets their measurements on their little stick or fucking Lego tower or fucking pole dancing pole, whatever the case they might be measuring on, right? So it is not having to track it moving around, right? Because it is above this one specific spot at this one specific time. Now that we have that, and now that we have the angles, we can triangulate it however the fuck high up it is. 50 miles, 100 miles, a quadrillion miles. Because we got the angles, and we got the exact time, and we have the location. We have the distance. So you can stop trying to spin it. I know you might not understand it, or you do, and you're trying to be dishonest, but I'm not going to allow it to go down that route. Regardless of if it's moving, if everything is synchronized, and everybody takes it at a specific coordinated time.
How do they make sure the stick is absolutely vertical?
The stick is absolutely vertical, right?
How?
So you probably have to use some leveling devices.
Like what?
Well, I know you got your spirit levels, but those aren't the most accurate.
Vertical, not horizontal.
Yeah. So you can use a flumbus.
A what?
Or a flumbob. Measure vertical, up and down. Not all that hard to get straight up and down.
Okay, so you've got 2 flumbobs, rounds. At which point will they start deviating?
At which point you start deviating, or if you get them up.
How far?
Perfect.
After a
if
meter?
You get the.
Will there be deviation a meter apart?
Will there be deviation a meter apart? No measurable difference.
Will there be parallel? Absolutely parallel, yeah?
Well, no measurable distance.
Will there be
There's
parallel
no way.
Or not?
No measurable distance. No measurable difference.
Can I be in... on. You can open your mic now. Unmute yourself.
Thank you. I'm sorry, I was driving and I had to open up my thing and everything.
Right.
But thanks. No, I was just gonna say you can just use a square just to answer that question. You're saying, well, how do you get vertical? You just use a square. But anyways, I think someone said it.
Yeah, I mean you can use Legos. Legos are pretty vertical.
Use a square? What do you mean a square? What does that mean? I don't know what you mean.
Oh, those little carpenter key squares. Yeah.
Like a square.
Yeah,
No, well, so
triangular things
we call them squares. They're like a triangle. They're like a 90-degree right angle. So whenever we have like a column and we're putting a beam across, and if you want to make sure it's level, and square, right? Because on the second floor, you already level up the first floor, blah blah blah. You just put a square against it, and then if it's right, it's right. That's it. Simple, easy.
So we've got that vertical one stick. How far until that other stick, bob?
There doesn't have to be another stick.
Yeah, we want to check the angles. Yeah. If the stick,
so you have your stick out. So you have
the stick should be deviating, right?
So you have your area in solar.
Hold on. Will those sticks be deviating?
Well, if the Earth is round, then they're not going to be parallel to each other.
Right, they're not going to be parallel. So that's what I'm asking you. How far? We've got the 2 plumb bobs. A meter, you said there will be no...
measurable.
No deviation.
You won't be able to see it with any kind of like measuring device.
The meter is completely flat and horizontal. Yeah?
No. This it is incredibly difficult to measure 1,000th of a 1,000th of a 1,000th of a degree.
What are you talking about?
Just saying, there's no measurement between a meter. Over a meter.
Yeah. I said, like, it is incredibly, incredibly difficult to measure 1,000th of a 1,000th of a 1,000th of a degree.
So that we can say is horizontal.
Parallel, you mean?
Yeah, we've got a horizontal between plumb bobs.
Well, again, they're not. Again, hold on. Again, I didn't
Why you
say that.
saying? Why
I
you
didn't.
saying if the
I
Earth
didn't say
is
that.
flat?
I'm saying
Like,
that on a ball over the course of 1 meter, they're not parallel, right? But their difference in angles is a thousandth of a thousandth of a thousandth of a degree, which you will not be
Assuming
able
you're
to
on a
measure.
board.
Assuming we're on a ball.
But as it stands, we don't know if we're on a board, do we?
No,
Can't
that
measure
again, I don't see what that has to do with the
because we
price of tea
can't
in
measure
China.
deviation between those two plumb bobs.
Okay, cool. So again, what does this have to do with the angle of the shadow?
Because the angles would have to be vertical, and you didn't show how they use. You didn't even know what device they didn't. They didn't use that device to make sure the stick was vertical. No one has ever done this. Make sure their sticks.
Yeah, they have.
Who? Where? Show me. Let's have a look.
I don't know, so that we have videos of people redoing air tossing these experiment where they
Yeah,
use
but how
nice
do they know
little
their stick
devices
is
to get it
straight?
perfect. Because they use all
Oh.
sorts of different devices.
No,
they
they
use like
haven't.
again, like you said, like
he
they like the
said no
triangle.
You're making it up
measurable.
now. You're lying. Show
No,
us
I'm
them
not.
doing that.
I
No
don't
measurable
want
deviation, right?
no
Making it up.
measurable
Tell the
deviation
story.
Is
over
that
the course
correct?
of 1
Is
meter.
that correct on a flat Earth?
Show me someone putting a stick in the ground and then leveling it, making sure it's vertical. Vertical, absolute.
Yeah,
Show
so
me a flat earther asking
I'm not
an
sure.
intelligent
I'm not
question.
sure why I'm having to do that. If all I'm saying is if we do this properly, we can get the angles right. I'm even assuming on a flat Earth. I'm trying to help you here, chemo, which is what you're not understanding.
No, because
Right?
I'm saying that you're going with the assumption that there be.
No, I'm not
deviation.
going. There's what?
There'll be a deviation. You're assuming that.
No, so all I'm saying is if you want to create an accurate flat Earth map, you get one place
We
that's solar
already
noon.
have a map, which is Google Earth. When they zoom in, you get the real images, real Earth. When they zoom out, you get the cartoon fake CGI. So we just remove. If we were to just remove the CGI from Google, all you'd be left with is a flat map, no fake curve that they put in there. That's a drawing, animated. So we can disregard all the animation and just work with the real images.
And that's
So
because
hold on,
you
so
said so, right?
There's a
chemo,
flat
hold
Earth map
on,
there.
time out. So chemo, we know the height of the sun, 3,600 meters or miles high, right? This
No, we
goes
don't
from
know the height
other.
of the sun. We don't know.
Yeah, we do. 3,600 miles high.
How did you measure?
Where
it?
have you witnessed
because-
the plumb bob deviating
How
at?
did you measure the height to the sun?
From other people redoing air tosses experiment over roughly the same known distance, right?
How
Using
you,
this.
go on then.
need
How
to
do they measure the
So
distance to
hold
the
on.
sun?
examine that.
So hold on. Using Google Earth, they got the distance between 2 points.
No, how do they
within the
measure the
United.
distance to the sun?
We're looking for North America and
I'm giving
Australia.
you that, right? You use
Earth.
triangulation.
Go on then.
Yeah, you use triangulation.
Go on then.
Where's
What's the
the
first step?
deviation in there?
Go out. We see
Can
the
you,
sun.
who is fucking spinning monkey ball, dude?
So look, just walk me through the steps because I like steps. I need steps. That's the only way.
And
we
so
can understand
again,
these
if you
things in the
have
process.
a known distance between 2 points, one of them is at a 90-degree angle, the other one is not at a 90-degree angle, and you're trying to find the distance to point C.
No,
now that
do
you have
it
a
now,
90-degree
like,
angle,
go through it. So you're outside. You see the sun. What are you gonna do first?
I'm trying to get to that. Okay, so I'm trying to get you to understand basic geometry. Okay, you have a 90-degree angle, you have a non-90-degree angle, right? You have a triangle. That's why they call it triangulation, right? You have points A, point B, and point C. You're trying to figure out the distance from point B, or in this case, it would be point A to point C, right? The point A is at a 90-degree angle between B and C, right?
How have you established that?
Because at point A, there's no shadow, which means that point C is directly above it.
Go on. I mean, again, we'll work with you, but remember, this is all you assuming all of this.
No, I mean, again, if you do it properly, you can measure your thing and making sure it's completely vertical,
Well,
right?
who's
And if
doing
it
it
casts no shadow, that just means that the sun is directly above you at solar noon, right?
Well, who has done it properly?
Well, I'm just saying, like, this is how you could do it. You're more than welcome to go to the fucking tropics and wait for solar noon to occur,
Then
and then
I
do
have
this
to
experiment.
presuppose a ball.
No, you're not presupposing a ball. You're presupposing flat. All you're doing now is trying
I'm
to
not
find how
presupposing.
high.
I don't want to work like that. I don't want to presuppose anything.
Okay, cool. Okay, so you have one of two options: either the Earth is round or the Earth is flat. All right.
No, that's not the option.
No?
We have no idea what the shape is.
Okay, cool. So we can take a look at different models. If on a flat Earth, you can use this method to figure out how high the sun
We don't really live in a
is.
model either, so...
Okay, cool. So at the end of the day, if you want to say that the Earth is flat, here's what you can do. You can use these triangulations instead of calculating the circumference of the Earth. You can use those same angles to calculate how high the sun is
That wouldn't
by
work.
simple triangulation.
Wouldn't
Yes, it
work.
would. Yes, it would.
Because we don't know how the sky works.
You don't know how the sky
Yeah.
works.
None of us do.
Can I ask something?
What's up?
In your calculation of the triangle, what exactly if you don't mind me asking, what exactly would you be calculating? What you okay, you keep saying I have the angle, but what
I'll
is
draw
your
an MS Paint for
formula?
you. I'll calculate
What?
it for you're using sine and cosine and perhaps tangent.
Okay, so to get that, what do you need? What measurement do you need to get that?
Let me draw this out in MS Paint for you, okay?
Now we're talking.
Yeah,
Get the
so
demonstrations
can y'all
out.
see this? So we have
Yeah.
our sun here. Let me draw this. Okay, we have our sun. We have the ground. Oop, I want to keep that yellow. We have the ground is yellow. Or we'll have the ground as green, right? Sun is directly over this point right here. And we'll do this. We'll make like a nice little pole right here. Nice. Oh, that's not directly over it here. Let me move it right there. Right? So we have our little pole right here, or a fucking well if you want it to be a well. Right? Either way, regardless. Now you have your 90-degree angle right here, and I'll show that with red. Right? So you have 90-degree angle. I'll have to move this thing over, but imagine that this thing is perfectly lined up, right? This is hard to do in MS Paint when I'm a fucking ape. Right? You have your 90-degree angle. You also have your known distance between right here and another point. We'll make this another tower. Oops, that's not what I wanted. I wanted this. Alright. This thing is causing a shadow which we'll represent with this, and it'll go out, say, oh no, I'll make the shadow because we got to calculate the angle of the light, right? So the light, oops, is going from the center right here down past the tip of that object, and it is creating a shadow right at the end, right there. So now we have, oops, this shadow right here. So now we have our beautiful two angles. We have, let's see if we can highlight this a different color. We have the 90-degree angle right here. And then we have whatever the fuck angle right here. And we know the distance from these two angles. Now we can use some trigonometry to figure out. So this is a known amount, this is a known distance, this is a known angle, this is a known angle. Now we can use simple trigonometry to figure out this thing's side length right here. So we have, let me undo some of this, I'll start labeling it. So we have, where's this? We have side A, we have side B, oh no, this would be C, right? We have side B, and we have side C. We have angle A, we have angle C right here, and we have angle B. Since we know the angle C, we know the angle A, we know the side length of B, now we can calculate with simple trigonometry side A, thus giving us the height of the sun. Yeah, sorry, I'm a vapor. That's all we have to do. Easy as that, simple trigonometry. Most people have learned it in the 9th or 10th grade. And it works. That's why triangulation works.
All right, so can you calculate that then? I want to see how you get it.
Cool. Throw in a distance right here. Oh no, I can't really calculate it because I don't know, right? I mean, if you give me just one angle and one side,
So
I won't be
let's
able
say that. Oh yeah, we don't know the distance. We don't know
Oh yeah,
that distance.
yeah. So we don't know distance B. I mean, we can throw in a random distance.
All right, say 1,000 yards.
Oh, it'll have to be something like miles. Come on, let's think big. But 1,000
Oh,
yards,
okay.
we can work with that. We can do 1,000 yards, right?
Well, let's go. Let's do like 5 miles across then.
All right. Oops. Control Z. So we'll just do 5 miles. All right. And what do you want this angle right here to be? What do you want angle A? We know angle C is 90 degrees.
Yeah. Okay. I don't know the angle because I haven't measured it 5 miles away.
No, so we're just
We'd have
coming
to-
up with with assumptions, right? I'm showing you how the math works.
Oh, okay.
So we
All right,
we have 5.
let's
just say
say that's a 45-degree angle.
a 45. Oh, that would be easy. If this one's 45, if angle A is 45, angle B is also 45, right? That means that side B and side A are the same lengths.
All right.
So this would
5
be
mile upside.
Yeah, that would be 5 miles up, right? If angle A was 45 degrees.
Yeah. Okay, so in reality, we went to go do this.
You wouldn't get 45 degrees on angle A.
Well, of course, but it would be easy to calculate if we were truly directly under the sun, right?
Yes, if you're truly under the sun at solar noon, which happens at one point of the year for every location in between the tropics on a specific day. They're not all the same.
Yeah, we'd have to.
You'd have to go to the tropics and wait for that specific day, have a known distance of somebody outside or away from there, and then you can calculate that. Then you can figure out how high up the sun is by using simple trigonometry, assuming flat.
So who has done that? Anyone?
Lots of people go out and get measurements, right? So we can use their measurements and just assume flat.
Okay, so
Like you could take a look at Eratosthenes' experiment and instead apply those angles that he got to a flat Earth, which is where everybody comes up with 3,600 miles up in the air for how high the sun is.
okay, so then didn't they say though that that's unfortunately that can be on either model, right? Flat
Yes,
or round.
No, that's what I'm saying. You could apply what he got to a flat Earth, assuming
Yeah.
flat, and then that's how you get 3,600 miles for how high up the sun is.
Only if you have 2 points, right?
Yeah, only if you have 2 points.
You get a third point, your flat Earth falls apart.
Yeah, if you have a third point, I'll get to that, right? So what we've seen in other demonstrations, I don't want to delete this. Shit. So let me see what I can do. If
So
you have a
the flat Earth falls apart, but has anyone gone to the tropics and measured 3 points? That's what I'm trying to get at.
Yes.
If it's so easy to do, has it been done?
Yeah.
People who make maps have measured a lot more than 3 points. You understand that you don't get a map without measuring.
Yeah, so I'll show you why. I'll
People
show
who
you.
make maps are taking shadows and calculating it,
They
or
use
they're just
different
marking
methods.
coordinates. Yeah, then why are you bringing it up then?
Nowadays,
If it's a different
but
method.
back in the day, they could do it with shadows.
No, I'll show you what we mean, right? So assume I have enough space to make the rest of this thing shadow, right? We'll do this as point D, right? So its shadow will be somewhere off in the distance, right? But
Okay.
what you notice when you get like different shadow lengths, when you use more than 2 points for Eratosthenes' experiment, what you'll notice as like the further away from point C that you get, the angles, oops, wrong tool. The angles don't really match up with reality, right? You match up this thing's shadow length, you get a point that's even further away,
Yeah, okay, the
following
third
that same
point.
line. Yeah, and then you see this trend, right? Where the further away you get, the more away from the sun these shadows are pointing on if you assume flat. Which is not really helping the case for flat Earth, because when you take like the lengths between all these points and you apply it to a globe, all of them show parallel, which is what we would expect to see on a globe.
Why can't it be done with 5 points?
Why can't it be done with 5 points?
Yeah, like if you took the shadows of
No, that's what I'm trying to say is people
northeast, southeast, like, yeah, I mean, and you took 5 points.
So you don't necessarily want to have, like, say you can have like another point right here, right? On the other side. This wouldn't really help either model either, to an extent. I could be wrong. Somebody can correct me if I'm wrong, but if you have another point on the opposite side of point C, and you have its shadow length,
And what I mean by 5 points is you'd put that one that's going to have no shadow, and then you put one to its east, west, north, and south point of it.
Yeah, assuming you're on a ball and everywhere away from you curves downward.
Well, the problem is you can have several triangles that solve for the same sides and similar angles. So these triangulations get increasingly off as you get further and further away from the object. You'd have to have the specific rays at their specific angle from the point source to even begin to solve the triangle properly. Otherwise, you have up to 2 triangles that, solve for something at, such and such an angle, at such and such a distance or whatever. It can be, very hard without, verifying it by actually going up to the object. You'd have some sort of visual impression on the object, which triangulates to here, but you need to back it up with, actually going to the object and getting a raw distance. Otherwise, at best, you have a visual impression that may not quite be the case.
Right, that's coincidentally all parallel.
Parallel just gives a big wiggle room. You could put anything a great distance away that's huge. It's just huge wiggle room at that point. It's meaningless. So you just have a model that gives you a huge amount of wiggle room with practically any angle that you want.
You said he came up with 3,600 miles.
Yeah, roughly 3,600 miles.
And do you have a problem with that?
I'm not giving my opinion on that. But all I'm saying is if you want to find the height of the sun, that's how you do it, and it correlates with, or it seems to show time and time again.
Well, why do you think he thought that? It's triangulation, and he gave you it there.
No, so assuming flat, right? This would be how high the sun is. 3,600 miles high. Now what I'm saying is, since you know the height of the sun, and you have and you can go out anywhere in the world, now you can get angles. Well, now you can get 2 angles, right? You can get the angle away from how far north you're looking, and you can get how high up and down you're looking, right? At a specific time and day where you have one person within the tropics on their solar noon figure out the 2 different angles, left and right, up and down, to figure out where on this little spinning disk you are, if you all take your measurements at the same time. You can use that to actually accurately form your flat Earth map.
Yeah, I have no problem with that.
Yeah. So this would be.
My question is, if the math that you're saying it works, then when he did it and he came up with 3,600 miles, when did it turn to 94 million miles?
He took a second measurement.
Yeah, no. So he wasn't. No, so so he wasn't measuring for how high up the sun was. Eratosthenes was using these angles assuming round, right? Which is why I'm saying you can use the angles that he got and apply it to either round or flat. If you're applying it to round, you can use those to determine.
So they took a second measurement. So they took a second measurement, and then.
No, so what I'm No, so what I'm trying to say
They
is
got different numbers. What?
no. What I'm
Then
trying to
that
say
doesn't
is
mean it's okay. Go ahead.
so what I'm saying is Eratosthenes assumed around. He assumed parallel rays, right? Making those assumptions, you can use those angles not to triangulate the sun, but to figure out how round the Earth was. If you're
So
assuming,
who debunks his 3,600 miles?
nobody debunks it. The experiment, like when people redo it every year, it continues to give you this number. Only
Nobody
assuming
debunks his triangulation of the sun. You're saying?
no, nobody debunks that. Nobody can debunk it. Nobody can debunk the math.
Nobody can go 3,600 miles up.
No, of course you can go
What
36.
the fuck?
You can go 3,600 miles up, yes, and you're never gonna reach the sun.
Jesse Johnson got 1,500 miles up
Well, yeah, I'm
when he
talking about
touched
debunking.
math up to 2 decimal places. So it may not even be that far, depending on how you use the math.
Jesse Johnson, who's that?
I'll put its video in the chat.
Because I would assume that he's
Is
just
it-
inept.
Is it the same source that gives you your story, Lemon Bird, about objects magically disappearing into the horizon from the bottom up due to perspective? Is this the same source of the same shit?
Yeah, you can get any distance you want to the sun on a sphere. If you assume it's
No, so the way they did it, the way they found the distance to the sun, is they used the same method, figuring out the triangulation of the sun, like I mentioned, instead doing it to the moon, right? So they figured out the distance to the moon. So let me draw the Earth from what I remember. So we have the Earth, and we know that the only time the moon is we have a half moon is when the moon is at a 90-degree angle to the sun compared to the Earth, right? So let me draw this over here so I can get a better representation. So we have the Earth, we have the moon. Oh, that's shitty. That's way out of. There we go. We have the moon. We'll move this. We have the half moon, right? So half of the moon is illuminated on the visual side of the Earth, right? So that means that the sun, oops, wrong tool. The sun is at a 90-degree angle. It's shining down right here at a 90 degrees. Oops, come on. Where's my other tool? To right here, right? So this is a 90-degree angle. And so again, the distance to the moon was known, was calculated using triangulation. So again, we have, where's this?
At best, you'd get a ring that corresponds to the sun circling over the surface with several different positions at several different times of day, roughly.
So we have.
So it wouldn't just triangulate to one position.
So
otherwise, you could all take your measurements at the same time, temporally.
So we have side A, we have side B, and we have side C. We have angle C, which we know is 90 degrees. We have side A right here, or angle A. We have angle B. So they figured out the distance from C to A using the method I previously shared with you. I think it was actually a different method, but kind of following the same triangulation idea. And so then now we have this phenomenon here where we have a 90 degree right here. So that's 90 degrees for C. The known distance is B. So we have known distance. We have this known angle right here, which is 90 degrees. Now we can plug that in through tan to figure out this thing's length right here. So if I remember the equations correctly, it's it is the length of side B times tangent times 90, if I remember correctly. I could be wrong. It's been a little while since I've taken geometry. But you use either side, or
They have to measure the exact angle. It's not.
No, so like what I was trying to say was, since the moon is at a 90, the only way we get it being a half moon is when it is at a 90-degree angle to the Earth from the sun.
You got a sun that's 1,600 miles
The issue
away.
is it's not exactly 90 degrees.
Math doesn't really add up to that.
They have to take the arc tangent of the actual angle.
If you assume the circumference at the equator of 24,901, and you take how long the sun circles in 1 second, if you take the tangent of that, basically you get 1,600 miles away for the sun. You take the arc tangent of the height of the sun divided by the distance it travels in 1 second at the equator, and
I'm
that gives
watching
you
the video.
100.
So I'm already seeing mathematical errors he's making. So this is actually kind of fucking hilarious.
What
You're not going to use arctangent. You're going to use sine for these things. So him using arctangent is just incorrect.
Arctangent is justified if you're using any the other two sides other than the hypotenuse. You're basically constructing a triangle where you have one side, which is the distance from the sun down to the surface, the distance from that subsolar point to where you are in 1 second, and the hypotenuse would be the hypotenuse going from that last side up to the sun. So if you take the arctangent of that, that could be used if you're going to go with anything other than the hypotenuse, because the tangent covers the non-hypotenuse sides of the triangle.
No, but hold on, Lemonbird. I'm trying to figure out where he got this 1,521 for like the distance between A and B. Well, I guess that's feet. So how does that correlate into that?
That's how far the sun travels in a second, assuming it's circling at the equator. So you take 24,901 miles at the circumference of the equator, and basically divide it by, I guess you could divide it by 24 hours in a day, divided by 60 minutes, and that gives you how far it travels in a second. So that would be the bottom side of your triangle.
The bottom side of your triangle. And so the change in angles, how was he able to break it down to a fraction of a degree?
He assumed it was non-90. Up to one decimal place, it would have to be at least 89.99. So basically, he took the tangent of 89.99 to 2 decimal places. I think he took it.
So he's just throwing in numbers
over the sun's distance it travels in 1 second.
So he's
otherwise you just get 90 and you couldn't analyze it.
Yeah, if you don't use it as take the actual angle, you get 89.86. So you can actually do a calculation on that.
And so that gives you 1,500 miles up to the sun, out to 2 places.
And again, so I'm curious as to where he pulled this number out of his ass.
The 1,500 feet number?
No, the angle A.
It's not 90, and it's out to 2 places.
And I'm also wondering why he used tangent instead of sine.
You use tangent for the 2 non-hypotenuse sides of a triangle.
No, so if you have angle B at 90 degrees, you have A, and you have sine C, or you have a side C, which would be that 1,521 feet. You would use sine.
You use tangent for the non-hypotenuse sides of the circle of the triangle.
So you can use. Let me double check with this. It's been a little minute. I'm pretty sure he's wrong though. So let me double check.
So basically, it gets a triangulation of up to 1,500 miles based off of that. But there's a bunch of assumptions that go into this math either way. But these conservative estimates appear to be much more attractive than a huge sun millions of miles away.
I've always admired.
Attractive. He said more attractive.
More attractive.
I've always admired Lemon's assurity, like his confidence. I've always admired that he speaks like Like you're telling a kid to like, you
Do you want
fucking
to
idiot.
be more like Lemon?
What?
Do you want to be more like him?
I
Been a
strive to
refresher
be.
for us all with trig and geometry and stuff, but I'd go with this since it doesn't assume a huge sun that's millions of miles away.
Yes. Him talking so confidently while being so wrong. Yes, that's something to aspire to.
I love it. I love it. I love it. But who's saying he's wrong? Just because you say he's wrong doesn't mean he's wrong. I mean, just do the math that he's telling you and see what happens. You can't just don't just hand wave what he's saying. Put it to the test. Put him to the fire. See if he's.
You understand that you can debunk every idiot for fuck knows how long on the internet, and that's not gonna change anything. Lemon is just making shit up on the go. You can't debunk that because you would have to actually sit down, parse the nonsense, and frankly, he probably doesn't even get what he's talking about.
Yeah, he's just spitballing ridiculous shit.
Well, instead of just hand waving him and calling him an idiot, why don't you just test what he's saying?
Seriously, and test all his claims, huh? Yeah, that sounds like a great
So
idea.
basically, when you take the tangent of 89.99 truncated and cut off at 2 decimal places, times the distance the sun travels in 1 second at a equator of 24,901 miles, you get a sun that's roughly 1,600 miles away, straight up.
For you, Lemon, are we boring you? This seemed trite and
I actually miss Lemon. Lemon uses pseudoscience versus science server. And why don't you go over there no more? I actually miss hearing you when you talk because it's funny to me. Because it's like you're smacking these people like, whoosh, whoosh. Like, I love it. Why don't you go over there no more?
I got a lot of studying I gotta do. So much.
Do you like this channel more? I don't know. I wonder if anyone's like double checking his work. Like, is anybody like?
Oh no, I am double checking his work, right? So I'm still curious where he got angle A. It doesn't really make any sense other than just
It's basically 360 divided by 24 divided by 60 divided by 60. It's the angle that you get in 1 second, which would be 0.004. Then you take 90 and subtract that, and you get 89.996. You just cut it off there, and you get 89.99.
If you're dealing with a spiraling sun, like that's going around a circle, right? It would make better like that. That wouldn't that would be more fitting if the sun was orbiting a circle, like orbiting a ball, right? And those two balls are on the same, or those 2 points are on the same line of latitude. No, because again, the sun is changing its angle in 2 different methods or 2 different ways, right? On a ball, or on a flat surface if it's spiraling, right? So this is either mathematically dishonest or mathematical ineptitude.
Then you'd get a range. But the range would still be conservative.
No. There wouldn't be a range. There would be
you have to check on the equator.
There'd be you would have to do it on the equator. No, not even on the equator. Let me show you why, right? So let me pull up MS Paint again. Am I still live? Yeah. So let me undo all this. So the reason why his math is fucked and why I think he's a fucking hack, right? Is he's on
It's because it doesn't fit your model.
No, it's
just
because
kidding.
It's because his math is fucking stupid, right? Because I'm like 90% sure he didn't do this at the tropics.
Yikes.
No. So obviously he wasn't on solar noon between these 2 points, or on the path like for solar noon. So we have like
a distance for the equator of 24,901 miles. We say that it does a circle within 24 hours. These are the figures that we have on file.
Where did he get these angles from? Was he in the tropics?
It's just using the same geometry and math. In 1 second, you go 0.004
Was
degrees.
he in the
When you
tropics?
subtract that from, what would that matter? That would just be the geometry.
Yes, it does. No, so the geometry would be he would still have to calculate for the curve of this path of the sun, right?
The curve?
Yeah, so look, right here. Look, take a look at my screen.
You get what? Like a
Can
circling path over a flat plane, wouldn't you?
Yeah.
Yes, that's what I'm trying to explain.
He's doing it. He's doing it.
Please watch.
Get roughly a triangle.
No, Lemon Bird, watch.
With one side being the distance from the sun to the subsolar point, and one side being the distance from the subsolar point to the distance it travels in 1 second, and the last side being the hypotenuse.
Lemon
You
Bird,
still
please
have
watch.
a triangle there.
Lemon Bird, can you stop ranting and actually pay attention to math and stop watching fucking hacks
I'm
on
just
YouTube?
trying to tell you what's going on while you're fishing for some sort of excuse to reject the math.
No, I'm showing you why his math is fucking retarded.
You're not showing how the numbers are off.
Yeah,
You're
I'm
just
trying
fishing
to
for
show
an
you that.
excuse.
He is literally going off of assumptions because his math is incorrect. Now you can
What
just believe
assumption?
something.
We assume that the equator is 24,901 miles. What assumption is he going off of that's incorrect?
Why don't you let him answer?
Yes.
He keeps on fishing for an excuse. I'm just waiting.
I'm not fishing for an Can you watch my fucking thing and shut the fuck up and learn something other than watching some fucking
You
hack
have
on
nothing. You're just looking for an excuse.
Your
You have nothing.
YouTuber has nothing. He's
Okay,
wrong
fine.
about his
And
fucking
write it down because I can't talk to you anymore. This is weak.
Holy shit. You're actually a fucking hack, Lemon Bird. Like, you just watch fucking nut jobs on YouTube and assume that their math is... Yes.
So do his math.
Yeah, so immediately the thing I saw wrong with the guy's math, right, is he is assuming straight distances, right? Meaning that these 2 points wouldn't line up, right? So he's trying to calculate the length that the sun took being a straight line in his math. The sun on a ball on like the spinning disc wouldn't be taking a straight path now, would it? Because he calculated the length of the length that the sun would travel from point A. Let me get this labeled.
He said around the equator, right?
Yeah, so from point A to point B, right? And then this right here would be the length of the sun. So we'll just do length of sun, right? We'll just do that for like the length of the sun, which is where he got that. Was it like the 1,500 something feet? My saying is he needs to calculate for the straight distance between these 2 points, assuming that they are both on the path of the sun, which he has not shown, to actually have any hopes of forming a triangulation. Because again, when he's getting that 89.99, that is for the length of the arc of the sun, not the straight distance between the sun. You're not going to get those angles with the arc distance.
At 1,500 feet, would you even be able to measure that difference?
Yes.
I don't think it would be a discernible difference.
That'd be fractions, dude.
Yeah.
Can somebody
Well, I mean,
summarize
when we're already dealing with fractions of a degree, it's good to be accurate with this.
Can somebody summarize what we're even talking about?
So, the hack in the video is talking
What
about
video?
the video that Lemon Bird is quoting for the 1600.
Can somebody re-link
Video
that?
you're talking about.
Yeah, so the guy was assuming for the arc distance when you need to assume for the lateral distance, or for like the true distance between these two objects, if you're going to want to have any hopes of doing that triangulation correctly.
Well, wait. While we were doing that earlier, while we were talking about it earlier, how were we getting point A to B measurements? Were we not including the arc?
No, we were assuming flat.
Okay, so then you're saying he's doing this calculation assuming a ball, right?
No, the guy in the video was doing the assumption on a flat disc.
Lemon posted a video?
Yeah, but he was using the arc distance and just throwing out some random percentage. Also,
when did
not
he put the video?
Do what?
I was saying, when did he put the video? I don't see a video from him. But
scroll up.
maybe. Yeah, maybe I missed it. Maybe it's way up there. Jeez, I'm way up here. Oh, here it is. Okay, the sun using trigonometry's angle validation. Okay, I see. So you're saying that on the ball, if it was a sphere, right? If Earth was a sphere, and the sun was where it's at, where it's believed to be, so then what would be the calculation then? I don't want to say you're wrong, he's right, you're wrong. I want to solve it and come to a conclusion so that way we could see who's right and we can see who's wrong.
So the way we figured out the distance to the sun was, I'll explain it to you again, I'll redraw it, was we did a triangulation using that same method I gave you, but instead throwing in the distance from the Earth to the moon. Lemonbird's not even here, so I don't know why I'm explaining this to him. I mean, he has some fucking whack job YouTuber who's making errors and assumptions in his, or just blatant assumptions in the angles that he's using, rather than actually doing the demonstration.
Hold on. Can you wait, hold on. Can you please stop telling people that they're wrong and just do the math and then prove them wrong?
Yes. Yeah. So I'll show you how they got like the distance to the sun. So they figured out the distance to the moon using triangulation methods, similar to the ones that I presented to you. So we have the moon right here. Yeah, so on our model, the only time the moon is a half moon is when it is at 90 degrees to the sun from Earth. I could be missaying that, but roughly I'll show you what I mean. So the moon is like literally right here. The sun is right here. Oops. The sun is right here, casting rays directly at the moon at a 90-degree angle. This isn't 90 degrees because I'm not good at drawing, but you can see what I'm trying to do. 90 degrees to the Earth. So we know that this we know that this right here is 90 degrees because it is a half moon. And in our model, the only time you get a half moon is when it is at 90 degrees to the Earth from the sun. So now we have the known distance. Oops. We have known distance B. We have angle B. We don't know angle B. We know angle C right here because it's a 90 degrees. We don't know side C, and then we have angle A, which is unknown, and we have side A. So we have angle, we have a known angle and a known side. Now we can figure out the hypotenuse.
What if the moon's bioluminescent and it's not directly pointing at the sun?
Say again?
What if the moon is bioluminescent and it's not pointing at the sun?
There's no evidence that the moon is bioluminescent.
Are you saying that the moon is
There's no evidence there isn't.
full moon when you're looking at it?
No, there is evidence that the moon isn't bioluminescent because the angles of the shadows and both the craters and the mountains that we see on the moon correlate perfectly with where the sun is in the sky. Always.
You're supposed to call me a fucktard and walk away.
Is it always a full moon when you're looking at it from the sun?
If you're looking at it from the sun, the moon will always be full. Kind of similar to how, was it Mars? I believe it is. We never see more, or we never see less than half of Mars. Mars is mostly illuminated, whereas Mercury and Venus go through phases, similar to the moon. Which on our model lines up perfectly with where the
Then how do we
planets
get
are
a full moon then? Then how do we get a full moon?
What do you mean? How do we get a
If
full
it's
moon?
always full, if you're looking at it from the sun, then how does the Earth get a full moon?
Says the smartest guy in your
Because
round.
the moon is not fucking perfectly aligned with the rotation of the Earth.
Yeah, so the moon bobs, right? It goes up and down in its orbit, right?
He
And
thinks that the moon goes exactly in the same plane behind the Earth every fucking night.
Oh, yeah, that's what I'm trying to say. It bobs up and down, right? And most of
he
the
was
time,
explained this. Pictures were shown how moon's plane of rotation looks in relation to Earth's plane of rotation.
Hold on, so you're saying it could be a full moon on the Earth and a full moon looking at it from the sun at the same time?
What?
Well, yes.
That's what you're saying. Yeah, that
From
doesn't
the
make
sun,
sense.
Sun goes forward.
That does not calculate.
Not compute.
no, but it would be up to the flat earthers to explain why the phases of the moon always seem to be pointing towards the sun in the sky, and why the shadows always seem to correlate with where the sun is.
Come on, it's much easier for the flat earthers to say, we don't understand anything, and nobody understands anything. You've been lied to.
If you ask them that question, they're going to tell you that it doesn't always point toward the sun.
Well, then they're going to have to find one shadow that doesn't.
They're
Whose
going to tell
model
you that. They're
has...
going to be able to show it to you. They've done that. They've done that to all of us. They show us the shadow of the pictures on the globe, the wax.
What?
Yeah, when the moon is not in a crescent moon, when it's in a crescent moon, that's what it appears to be pointing directly at it. If it's not in a crescent moon phase, then it doesn't appear to be pointed direction that the sun's